Okay, so let's look at something called the combined gas law. So the combined gas law combines both Boyle's law and Charles' law. So we're looking at volume, temperature, and pressure. So the mathematical relationship, the equation that we're going to look at is going to be P1 times V1 over T1 equals P2 times V2 over T2. So what's important here is that temperature must be in Kelvin. And then pressure or volume can just remain in whichever unit it's given to you in. Okay, so I'm going to write out the problem for a combined gas law example. So it says divers working in the North Sea drilling platform experience a pressure of 5.0 times 10 to the first atmospheres at a depth of 5.0 times 10 to the second meters. If a balloon is inflated to a volume of 5.0 liters, that's the volume of the lung, at that depth and at a water temperature of 4 degrees Celsius, what would the volume of the balloon be on the surface of the water, which is 1 atmosphere of pressure and a temperature of 11 degrees Celsius? The surface is 1 atmosphere of pressure. We'll say 1.0. And temperature of 11 degrees Celsius. Okay, so this is a long problem, and I wrote out a long problem on purpose because a lot of times when you're working with some of these calculations, they will be long and include information that you don't need. And when you're taking a quiz or an exam, you're not going to be told this is a combined gas law problem. You're going to have to read the problem and get the information out of the problem and see which formula am I going to use to solve this problem. So that's something that is really going to serve you well if you start trying to do these problems without already knowing what type of problem it is and then seeing, based on the information that's given, how would I go about solving this problem. So let's just see what information is given to us here. So here I have a pressure. I'm going to call this P1. And I have a depth. So I'm just going to call that D. I'm going to write depth, actually. And then it says if the balloon is inflated to 5.0 liters, that's V1, at that depth and a water temperature of 4.0 degrees Celsius, that's T1, what would the volume, so that's going to be V2, what is that volume, of the balloon on the surface, which is 1.0 atmospheres, that would be P2, and a temperature of 11 degrees Celsius, that would be T2. So you see, this problem gives me everything I need for the combined gas law. It also throws in here a depth. You do not need this depth. This is extra information. And this is something that students can get really hung up on, is when problems throw extra information at you and you're trying to figure out some way to incorporate that into your math, and it just doesn't belong anywhere in there. So P1, V1, T1, P2, T2, we're solving for V2. So I'm just going to write everything out over here on the side just so we can all see it out of the problem. T1 was given to us as 4 degrees Celsius. I'm going to go ahead and add 273 to it to get 277 Kelvin. That's what we'll use in our problem. V2 is what we're solving for. That's a question mark. P2 is 1.0 atmospheres. T2 is 11 degrees Celsius. Again, don't forget to convert it. So now we're just going to solve for V2. So P1 V1 over T1 equals P2 V2 over T2. So I'm going to move all of this around before I put the numbers in, just to make the calculation easier. So if it's and I want to solve for V2, I'm going to multiply both sides by T2. I'm going to divide both sides by P2 to get V2 by itself. So now we've just rewritten it to this, so we can plug all these numbers in and solve for V2. You do not have to do this. You could put all of the numbers in and then rearrange it that way. Totally up to you. And then you should get a volume with 2 significant figures, because that was the fewest number of significant figures in the problem. You should get a volume of something like 260 liters. Remember, this number has 2 significant figures. Zeros in a number that do not have a decimal place at the end of a number are not significant. 260 has 2 significant figures. You could also write this as 2.6 times 10 to the second liters. That would also have 2 significant figures. Make sure that you're answering problems with the correct number of significant figures and the correct unit. So for this to be a correct answer, you need to have the math correct, the number of significant figures correct, and the unit correct.